The title of today's lecture will be two parts, recursive and array. Actually, yeah, those two are totally different, but I guess I can just put them into one slide. The first part of our class will be about the recursive. What is recursive? And we are going to learn about some recursive variants. And next, I'm going to explain about array. So what is array? So we are going to learn about the sequence of data and what is global array. So in the middle of the class, we will do practice. How to deal with the recursive, how to deal with the array. First, recursive. So what is recursive? In some case, you can see the literatures mention about recursion. Okay. Recursion. They are the same. We call it is recursion. It is a method that calls itself until a condition is fulfilled. This is a method. So you already learned from the object-oriented programming. We have method. When we have class, and then we have fields. What are fields? Fields are the data members. For example, we have name, or we have the birth date, we have the age of the person, and so on. So the data from a person, or a data from a product, or a data from a user, and etc. And we have methods. So the methods are the behavior of the class. For example, I want to get the name, I want to get the user ID, I want to get the birth date, and etc. Or I want to set the name, I want to set the age, and etc. So the methods are a kind of function. Okay. Now, when we do with the recursion, it means we are using the method, and the method will call itself until the condition is fulfilled. So the core idea is we are breaking down a problem into smaller, self-similar subproblem. If you look at the loop or repetition, we have 1, 2, 3, so on. Okay. Here we have 1, 2, 3, 4, and so on. So it is a kind of repetition, and you are using for loop usually. Now, instead of using for loop, we are going to use recursive. So the recursive formula will be something like this one. Fn it equals to the Fn minus 1. When we do with the Python, it will be something like this one. We have a def, it indicates the function, and then the function name is countdown. And then we have one parameter, and once we enter the statement, we will print the I, and then we will do the countdown, I minus 1. So this is a kind of repetition. If you run this into the Python code, for example, I put the I equals to 3. Okay. Then it means I'm going to start the countdown from 3, and then I will check 3 minus 1. 3 minus 1, then it is 2. So I will call the method again. It becomes 2, and we will print 2. And then 2 minus 1. Then I will go to 1. Then I will print 1. And then 1 minus 1. I will print 0. And then go back again here. Now it becomes minus 1 and so on. So it will be an infinite loop. In order to complete the recursion, we do not want to have the infinite loop, so we need to have a base. We call it a base. So this is a Python method with base. It means when the condition is satisfied, so we have the countdown n, and then we want to print n. Now let's look at the condition. If n is less than or equal to 1, then return. So this return means we just stop. Otherwise, let's do the recursion, or let's do the recursion. Because this is the recursive call. And in the mathematics, we can just use this formula. Fn, it will be an empty when the n is less than or equal to 1. Otherwise, it will be Fn minus 1. Okay, so else means if the condition is not true, then we use this formula. If the condition is true, then it is empty, or we can say it is completed. In the recursive methods, we have two kind of concepts, or we can say this is the content. Base case. The base case means the values of the input variable for which we perform no recursive calls. If there is no recursive calls, so we call this is the base cases. So there is a kind of note. There should be at least one base case. When you do with the recursive, you should have at least one. Every possible chain of recursive calls must eventually reach a base case. So whenever you do with the recursive, the recursion or the loop should go toward the base case. Okay, so that's the condition. And then the recursive calls. The recursive calls means the calls to the current method, and its recursive calls should be defined so that it makes progress towards a base case. Now we can see another example. This is an example about factorial. I'm not sure what is the Korean of the factorial. So the classical example of factorial is n exclamatory sign. So this means that we have 1 multiplied by 2 multiplied by 3 until n minus 1. Multiply n minus 1 until we have n. Okay. So it means if we have, for example, 3 factorial, then it means this is 1 multiplied by 2 multiplied by 3. If we have 5 factorials, then it means we have 1 multiplied by 2 multiplied by 3 multiplied by 4 multiplied by 5. Okay. If we have this condition, we can do with for loop. But now, how if we use recursion? Then we have a recursive definition. If n equals to 0, then let's return 1. If not, then let's do the multiplication, which is n multiplied by fn minus 1. So fn minus 1 will be, go back to this function. And then we will check again. If n already 1, no, sorry, if n already 0, then let's return 1. Otherwise, we will do again this formula. If you see this Python method, okay, you can see the function name is factorial, and then we have one parameter, which is n. If n equals to 0, then return 1. So this is the base case. Otherwise, let's return n multiplied by factorial n minus 1. Because this is the recursive call. In order to see how the code works, we can look at this kind of visualization. So the box, we have the box to show the recursive call. And then there the arrow from its caller to the callee. So we say this is a function. After we run this function, we go to the next. We go to the next. We go to the next. An arrow from its callee to caller showing the return value. So after we reach the base, so we call this is the base. Then we will return, 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 and return. So we got this is return. Now let's take a look one by one. Suppose I have the n equals to 4. Recursive factorial 4. Now, based on the method, we want to check whether n equals to 0. Since n now equals to 4, it means it is not 0. Then we will do n multiplied by f n minus 1. N minus 1, it means it is 3. Then this will be 4 multiplied by f function 3. So then I will have function 3. The function 3 means I'm calling the function here. I am calling the recursive factorial 3. We need to check n equals to 3. Is it equal to 0? No. Then we will do again n multiplied by f n minus 1. Then we will have 3 multiplied by function, and we use the parameter 2. The function with parameter 2, we call again the function with the parameter 2. Again, we check when n equals to 2, what is n? N is not 0. Then it will call the n multiplied by n minus 1. Because n is 2, then we will call f with the parameter 1. We call the n function with the parameter 1. Again, when n equals to 1, n is not 0. So we do the n multiplied by n minus 1. We have, okay, let me go here. 1 multiplied by function 0 or n minus 1. We call the recursive factorial with the parameter 0. Now n equals to 0. When n equals to 0, it returns 1. It returns 1. So we will go back to the previous function. So in this case, we go back here. 1 multiplied by the result of function with the parameter 0. Function with parameter 0 means the result is 1. then it will be 1 multiplied by 1. Then we get 1. And after that, the result of this will be going up into n equals to 2. So the result 1, it will be 2 multiplied by 1. Then we got the result is 2. We go back to the upper side, which when the n equals to 3. Then 3 multiplied by 2. Now it becomes 6. 6, it will be written back to the original when n equals to 4. Then we have 4 multiplied by 6. Then the result will be 24. So this is the way the recursion works. In the recursive, there are at least 3 kind of variants. Actually, there are more than 3. But for this chapter, I'm going to teach you only 3 kind of variants. The first variant is linear recursion, and then we will take a look tail recursion and binary recursion. Linear recursion. It creates a linear progression of function calls, one after the other. So the test for the base cases, it will be a simple stop. It begins by testing for a set of base cases. There should be at least one base case and always reaching the stop. It means every possible chain of recursive calls must eventually reach a base case, and the handling of its base case should not use recursion. So this is the condition. The base case should not use recursion. And using the linear recursion, we have at least one. So this is the condition of linear recursion. The recur once. It performs a single recursive call. This step may have a test that decides which of several possible recursive calls to make. So there can be several possible recursive calls, but it should ultimately make just one of these calls. So what does it mean? There can be several possible recursive calls. So maybe the function can be 2, f1, f2, something like this, but there should be only one time calling. Okay, so we call this is recur once. Define its possible recursive call so that it makes progress toward a base case. So the recursive call should go to the base case in order to stop the recursion. Now let's take a look on this example. We have an algorithm, linear sum. The linear sum means I want to sum all the n numbers in the array. I have an array 4, 3, 6, 2, and 5. The linear sums means I want to sum all these numbers. So it means 4 plus 3 plus 6 plus 2 plus 5. Like this one. Now, in the parameter of the algorithm, I put 2 parameters, A and N. The input, it is an integer array A and an integer N equals to 1, such that A has at least N elements. So if we have this one, n, it means the number of elements. The output will be the sum of the first n integers in A. So we can define the n. Let's say I want to know the summation of the first 5 integers. The first 5 integers, or I want to know the sum of 5 integers. Then 1, 2, 3, 4, 5. So the n can be defined as 5. Or I want to do only the summation, the first 4 integers. Let's say I have the a, comma 4. It means I want to sum only 1, 2, 3, 4. So I do not want to use the last element. I'm just going to use the 4 elements, and so on. So n can be defined with any integer. Now the algorithm works like this one. We have the base case. The base case means I'm going to stop when the n equals to 1. When n equals to 1, return A0. A0 means the first element. Otherwise, let's do the linear sum. The linear sum here, I'm going to use the array A, and the parameter will be n minus 1. In this case, I'm going to make sure that n will go to 1, and n should be higher than 1. After we call again the method, we will do the summation with a n minus 1. So this is how we can see the algorithm. We call the linear sum a comma 5. It means I'm going to do the summation of the 5 numbers on the array A. And I will do the linear sum a n minus 1. So the number here is 5. Then I will do the a comma 4 plus a index 4. What is a index 4? We know that this is index 0, 1, 2, 3, 4. So the index 4 will be the last digit on the array. Okay. Then we can go to the next, which is linear sum a comma 4. Linear sum a comma 4. Is n equals to 1? No. Then we will do again linear sum a comma 3 plus a index 3. The a index 3 means this one. Okay. 0, 1, 2, 3. So it means 2. Then we will go to the next, which is the linear sum a comma 2, because n is still not 1. So we have a index 2. And so on until n equals to 1. When n equals to 1, so we will go back to the a index 0. A index 0 means 4. And then 4 will be the result. And then we will do summation with the result of the function. So in this case, I have 4. 4 will be added with the a index 1. It means 4 plus 3, 7. And then 7 will be added with the a index 2, which is 6. And then we got 13. And then 13 will be added to the a index 3. Then we will get 15. And then 15 will be added with the a index 4, which is 5. And then we got the final result is 20. So this is one of the example of the linear sum. There is another kind of algorithm, we call it reversing an array. We have the array A, and we have I and J. So this is another kind of linear recursion. The input is an array, and the I and J should be non-negative integer. What is non-negative integer? We have non-negative and sometimes people confuse with positive. What is the difference between non-negative and positive? In the mathematics, usually we use the non-negative. It refers to a number. It refers to a number higher than or equal to 0. So when you include 0, we use the non-negative. If you use positive, it means it should be higher than 0. So 0 will not be included. That's why they call it the positive. So if you look at the word non-negative, it means we will include 0 for the index, whether it is I or J. The output, it is the reversal of the elements in A, starting at index I and ending at index J. So if I less than J, then swap I and J. And then we will do again for the array A, I will be added by 1 and J will be minus by 1. Okay, what does it mean? Let's say I have the I have an array. So you already know an array, or let's say we have a list. Okay. Let's say I have 2, 5, 1, 4, and 3. So this is index 0, index 1, index 2, index 3, and index 4. Suppose I'm going to put this as the array A. This is array A. And then I'm going to start from index 0, and it will be ended at index 4. So I'm going to swap. Or yeah, we call this is reverse. It means the final goal, I want to make it as an array, and the sequence will be 3, 4, 1, 5, 2. So we got this is the reverse. Okay, we want to change the order. We are going to swap this one. If I is less than J, so now 0 is less than 4, yes. Then swap the AI with AJ. It means I'm going to swap the index 0 and index 4. And next is I'm going to swap. This will be 3 and this will be 2. The remaining is still the same. And then we are going to do the recursion. The array A, now I will be added by 1 and J will be minus by 1. Then I will have A with 1, comma 3. Then after this, I'm going to check 1 is less than 3. Yes, because it is true. Now swap AI and AJ. Then it means I have already 3 and 2. Now swap this one, 4 and 5. Now it becomes 4 and this becomes 5. This is still the same. And then we do again the reverse AI plus 1. So I plus 1, which is 2, and j minus 1. So 3 minus 1, then it is a 2 comma 2. Now let's check. If I less than j, 2 less than 2, no, then stop or return. And this is the final result, or this is the same with one. Okay. In creating the recursive methods, it is important to define the methods in ways that facilitate recursion. Okay. In the previous examples, we have various kind of argument. In the first algorithm, in the linear sum, we have two parameters. In the previous example, in the factorial, we have one parameter. Okay. We have two parameters for the linear sum. For the reverse array, we have two parameters. So you can define the methods in a way that it facilitates the recursion. This sometimes requires we define additional parameters that are passed to the method. So in the reversal method, in the array reversal method, we define array a comma I comma j. It is for the convenience to do the recursion instead of only the reverse array a. If you use the array a like this one, then we may have some difficulties to do the recursion. So the Python code will be like this one. We have def reverse. S is the sequence or the array, and then define what is the starting index and what is the stopping index. If the start is less than stop minus 1, then let's do this one. So this is the swapping. The start will be the stop minus 1, and the stop minus 1 will be the start. And again, we will do the recursion. The recursion will work with the S, which is the sequence, and the start plus 1, it will go back to this, and stop minus 1, it will go back to this argument. We will stop when the start is less than stop minus 1. The other kind of linear recursion we can see from the computing powers. The computing powers means we have a base x, and we have the power function. We have p x comma n. X comma n means we can define with the mathematicals like this one, x power of n. So for example, if I have p 2 comma 3, then it means this is 2, which is the base power of 3, like this one. We can define the function px comma n. It will be 1 when the n equals to 0. So you can see if 2 power of 0, it means this is 1. Okay. If not, then we will do the multiplication. X, this is the base, multiply by the p, which is the power function, with the base x comma n minus 1. If you look at this function, this leads to a power function that runs in the on time. So we make n recursive calls. So we will do the n times for this one. So we can do better than this. What does it mean? We can reduce the number of operations. We don't need to do until n times. We can do with the computing square, with the recursive square. How? So we can derive a more efficient linearly recursive algorithms by using repeated squaring. So this repeated squaring means if the x is I think this is not the x, this is n, sorry. Okay, this is n. Oh, okay, I will change later. This is an image. Okay. So if the n is 0, okay, then yeah, we just make it 1. If 2 power of 0, okay, then it will be 1. So this should be n. And then if the x is higher than 0, is odd. Odd. Oh, okay. Odd means 1, 3, 5, 7, and so on. So if the number is odd, so if n is odd, we use this formula. If the n higher than 0 is even, then we use this formula. So what does it mean? If you look at this one, it is x multiplied by p x n minus 1 divided by 2. And then we have power of 2. If x is higher than 0, oh sorry, if n is higher than 0 and it is even, then we will do x, we will do p x comma n divided by 2 and power of 2. So I give you the example here. Now I have 2 power of 4. 2 power of 4. How can we do the multiplication? Then, because we know that it is even, we will do the function 2 x is 2 and then n divided by 2. N divided by 2, this is n. 4 divided by 2. Okay. Actually, we can just do like this one, power of 2. And then we know that this is 2 power of 2 and power of 2. We know this is 4 power of 2. Then the result will be 60. By using this one, the operation will be smaller than the n time, because we don't need to calculate for 2, 2, 2, and 2. So the operation here, it will be 4 times. But using this formula, it will be reduced at least half. So we don't need to do this one. We just need to do this calculation, multiply by this one. That means we will calculate at least 50% reduce from the original one. How about if the n is odd number? If the n is odd number, you can see 2 power of 5, it will be 2, 1 plus 4 divided by 2, and then 4 of 2. What is the meaning by 2 power? 2 power of 1? 2 power of 1 means dx. If there is 2 power of 1, it means this is the same with the number, which is 2. Or this is the same with the x itself. Then I have the 2 power of 1 plus n minus 1. Yeah. If you do with this one and by n minus 1, yeah, we will do again for the remaining if the number of this one is higher than 0. Then we will do 1 plus n minus 1, which is 3. Yeah. But we can just put the function here 4 divided by 2. It includes the x, so it becomes 4 divided by 2. And then if we have this one, oh, sorry. So if we have this 2, 4 divided by 2, power of 2, then we have the 2 multiplied by 2, power of 2, something like this. So it is the same with this. And then, yeah, at the end, if you look at the sequence, 2 multiply 2, power of 2, and then we have the, sorry, this one is 2, and then we have at the end 2 power of 2, which is 2, or this is now becomes 4 power 4 power of 2, then it becomes 16, then 2 multiplied by 16, then it becomes 32. So we get the 32. Using this formula, we have less operation. We don't need to do the 2 multiplied by 2, multiplied by 2, multiplied by 2, multiplied by 2, but we reduce this one and this one. So at least we don't need to do 5 operations, but we do approximately it is 3 operations, or approximately it is almost 50% reduced. Okay, so you can take a look on this 2 power of 6 and 2 power of 7. So using this squaring method or this recursive squaring method, now we have another kind of condition. When the n equals to 0, let's return 1. But when the n is odd, we do this function. When the n is even, or else, we do this function. Okay. By using this method, each time we make a recursive call, we say we halve the value. Okay. Half means we reduce the operation at least into 50%. Half means reduce into 2. Then we make the log n recursive calls. Okay. The log n means at least we reduce the n. It is not n anymore, but it becomes log n. That is, this method runs in the log n time. So this method actually it runs in the log n time, or it is more efficient than the general power n. It is important that we use a variable twice here rather than calling the method twice. So we have the variable n to indicate whether it is odd or even to split this function. Why? Because it is important to have at least half from the value of n. Okay, let me stop here. Let's have a break. I'll continue after the break.